So do you like this journey back to grade 11 and then back to grade 12, back and forth? No? Just bad memories from grade 11?
I don't even remember. I do, to be honest.
So here, this would have been this question in grade 11. How would you solve that question in grade 11? Well, you would have to factor. Now, you learned a couple of different techniques for factoring these. If you want to use any of your old techniques, that's fine. For the most part, in grade 12, the factoring ones are not going to be so complicated that you need an extra technique. You should be able to go directly to the factored part. Now, some things about factoring that could help you. You know that when you multiply things out, in English we use the word FOIL because you do the first ones, you do the outside ones, you do the inside ones, you do the last ones. If you do that with a trinomial, a pattern always occurs. The pattern is that the first ones always give you this one, the last ones always give you this one, and the outside and the inside are always like terms and they combine to give you the middle one. If that's the case, using that idea actually allows you to factor quite easily. Because if the first ones are 2x squared, there is only one option with nice numbers. You could use fractions and decimals and come up with stuff, but if it's going to factor, it's going to be most likely nice numbers. It would be 2x and x. Can you see that that's the only way to get 2x squared? And the last one, being a 1, the only way to multiply to get 1 with whole numbers is 1 and 1. The last thing you're going to look at is what are the signs going to be in the middle. Okay? I need to get a positive 1, so it's either both plus signs or both minus signs. Does that make sense? The only way I can get a plus 1 is if they're both positive or both negative. Now I need my outside, which is 2x, my inside, which is 1x, to give me minus 3x. In order for the outside and the inside to make minus 3x, can you see that they would both need to be negative? So there's a little review of factoring. It's actually, in this one, was super easy because there was only one chance for 1 and 1. There was only one chance for 2x and x. And then we just had to figure out whether it was plus and plus or minus and minus. At this point, we can now say I've changed it to multiplying. Two numbers multiplied to get 0. Either this one's 0. If this is 0, can you see that x would have to be 1/2? If this one's 0, then x would have to be 1. That's grade 11. Now we're in grade 12. Instead of x and x squared, you have sine squared and sine. Same thing though. Set up your brackets. Equal to 0. It would have to be 2 sine theta and sine theta to give you 2 sine squared. It would have to be 1 and 1 to give you 1. And then check your outside and inside, both negative, to give you the negative 3 sine theta. So here, sine theta would be 1/2. And here, sine theta would be 1. So this is identical to what we did in grade 11. The difference now is you still have to solve for theta. Is 1/2 on your pie plate? What family? Because that'll be your reference angle. Pi over 6. Sine is positive. What quadrants would it be in? Quadrant 1 and quadrant 2. Is your y-coordinate ever equal to 1? Yes. What's the angle? It's an axis family. Pi over 2. Perfect.
How do you know from 1/2 that it's the pi over 6 family?
You know from 1/2 that it's pi over 6 family because in your head, you would have gone back to quadrant 1 and said, where is my y coordinate 1/2? Because my y coordinate is sine theta. And so I think of this coordinate, I connect it with 30 degrees and pi over 6. But that's part of remembering your unit circle. Okay. Ready to increase the level of difficulty a little bit? No? you do? Okay.
If I must.
Just a little bit. I give you a hint and everything. This is a question that needs the big idea. Okay? The big idea is sine squared plus cos squared equals 1. We had three big ideas at the beginning of this unit. One of them was that sine squared theta plus cos squared theta equals 1. The reason we need the big idea is because if we went back to grade 11, for this question, you'd have minus 3y minus x squared minus 3 equals 0. And you can't solve that because it has an x and a y. You can't solve something with two variables in one equation. Do you remember in grade 11 solving systems of equations that if you have two variables, you need to have two equations? And that's where the big idea comes in, because sine squared plus cos squared equals 1 is really related to the equation of the circle that x squared plus y squared equals 1. So this would be equation 1, and now you've got a second equation. If you had two equations with two unknowns, what was the strategy you used to solve? You either isolated one and did substitution, right? Or you put them on top of each other and added them and used the elimination technique. Do you remember that? Okay? Vaguely. Now, for the isolation in this one, can you see that this one has an x squared and this one has an x squared? So that will be the easy thing to substitute in with one or another. In fact, I could rewrite this equation that x squared is equal to 1 minus y squared and then substitute it into the other equation. So that's what I would have done in grade 11. I'm going to do the same thing now in grade 12. I'm going to notice that there's a cos squared in both of those. So I'm going to take sine squared plus cos squared equals 1. I'm going to subtract sine squared on both sides and say that cos squared is equal to 1 minus sine squared. And then I'm going to substitute that into my original equation. So my original equation had negative 3 sine theta minus, and then instead of cos squared, I'm now going to write 1 minus sine squared. Minus 3 equals 0. So that's why this one added that extra bit of difficulty. Okay? The only difference between this question and the exam question, they don't give you the hint. They just say solve, and you have to recognize, hey, I have two different trig functions I need to substitute in. I need to use my big idea to figure that out. Now, what kind of equation does this give us? It gives us a quadratic equation because I've got a sine squared and a sine. So I'm going to do a little bit of simplification. This negative would get distributed. That's going to give me a positive sine squared. I still have minus 3 sine theta. Can you see here you'd have a minus 1 minus 3, give you minus 4 equals 0. And again, if we try to factor this, The only way to get sine squared would be sine theta and sine theta. But the last one, right, here's the first, here's the last, here's the outside and the inside. The last one you have more than one choice, right? It could be 4 and 1 or 2 and 2. So when you're thinking about should I write 2 and 2 or 4 and 1, you have to think about the middle term already. My outside and inside needs to make 3. Can I make 3 with 2 and 2? Only with a few mistakes, maybe, but no. But I can make 3 with 4 and 1. So it's looking like I should use 4 and 1. Now I have to decide on what signs am I going to use. It needs to be a negative 4. So one of them needs to be positive, one of them needs to be negative. And I need to get a negative 3. So I need to have my 4 to be negative. That makes my inside negative 4. My outside positive 1. Together that will make negative 3. I wrote it first just so that it's in, it doesn't matter when you're adding and subtracting the order. We like to write the highest degree first. Also, quadratic equations, if you write sine squared, then sine, then the number, that's more like a trinomial where you have x squared, then x, then a number. It makes it easier to factor. Now that we've factored in and it's equal to 0, we get sine of theta is equal to 4 and sine of theta is equal to negative 1. If a question is non-calculator, that means everything can be done with your unit circle. This would be a non-calculator question. So first of all, let's go to the one on the right. Negative 1 is on your unit circle. So you could do this without your calculator because one angle, when do you have the y-coordinate equal to negative 1? That's your x-coordinates, negative 1 or pi. Have to be 3 pi over 2. But on the other one, you have sine theta equals 4, and 4 is never on our unit circle. And so that technically means you should probably use a calculator, but this is still a non-calculator question. Not for this unit, but for the next unit, and for all other unit tests you would. And then on the final exam, you have to have it memorized again. Yeah. This should have been the last unit. Many people think this unit is the hardest unit. Okay. Also, you need to use this unit. You need to use this unit in another unit. So if we made it the last unit, that would make that other unit really hard. Proofing, you think, is the hardest? That is the next unit. And it uses this unit. It's not that bad. So this one on the left, even though it's not on your unit circle, you can do this without a calculator if you know what sine means. What does sine mean in a triangle?
It's the x no, it's the opposite over the.
Okay, so let's write this as 4 over 1. Can you draw me a triangle where the opposite side is 4 and the hypotenuse is 1?
No.
No. So that side's not possible. That's why you can do it without a calculator. If you try it on your calculator, you will get an error. But if you get sine or cos bigger than 1, you can't draw that triangle. It's not possible. Anytime that this fraction is bigger than 1, then that would mean your hypotenuse is smaller than your opposite side. Or if it was cos, the hypotenuse would be smaller than your adjacent side. And the hypotenuse has to be the biggest value. Okay? Other things that kind of give you a hint in that, oh, this is on the non-calculator part of the exam. I should be able to do it. It's not on my pie plate. Probably it's because that value is bigger than 1. All right. Next question. Can you see that it's quadratic? Okay, anytime something's quadratic and you're solving it, if you want to solve it by factoring, you have to make one side equal to 0. For factoring this one, for my first term being a 6 sine squared, can you see that I have more than one option? It could be 6 and 1 or 2 and 3. So I don't know what I should put down first because I have that option. So sometimes I just defer. Maybe I'll do that later. I'll look at my last term because it really doesn't matter if you deal with your first or your last. If I look at the last one, it's a 1. Are there any options for multiplying 1 with whole numbers? No. So I could already put 1s there. I know that it has to be 1. Now, when I go back to my first one and say, should it be a 6 and a 1 or a 2 and a 3, I can start thinking about my outside and inside a little bit better. It has to be the 2 and the 3. Because if I do the 2 and the 3, my outside's going to be 2, my inside's going to be 3. Do 2 and 3 ever add or subtract to give you 1? Yes. So if I do 6 and 1, let's try 6 and 1 here. My outside would be 6, my inside would be 1. Do 6 and 1 ever add or subtract to leave you with only 1 left?
What if you did 6 sine theta plus 3 and then sine theta minus 2?
If I did 3 and 2 here, what's 3 times 2? Not 1. Doesn't work for my last one. But your last ones have to multiply to give you this last term. Your first ones have to multiply to give you this one. Since always. So these have to be 1s. And if they're 1s, my outside 6, my inside is 1. That doesn't work. So they.
I thought the two numbers that you picked just had to multiply to let the two outside terms multiply to.
But you have to be careful because that will only work if there's not a number in the front here. Like if it's just x squared, that works. But if it's like a 3x squared, then you have to actually think about, you have to work with that 3 and think about it. So because there's a 6 there, I have to think about that. This is going to be 2 sine theta and 3 sine theta because that makes 6. This makes 1. I need a plus 1 in the end, so my inside makes plus 3, my outside minus 2. That'll work to get plus 1 in the end. What you really need to do after you factor something is you need to multiply it out in your head to double check to see if it worked. Sometimes the best strategy for factoring is to write one that doesn't work down just to get you started. If you don't know how to factor it, try one that doesn't work, multiply it out, figure out, oh, that's why it didn't work. What else? What can I change? What can I manipulate?
Aren't like the one and the negative one, aren't those supposed to add to positive or no, like the middle term?
So if I multiply this out, there's my first terms, green arrow. That would give me 6 sine squared, right? Then outside and inside I'm going to do in purple. This would give me minus 2 sine theta plus 3 sine theta. And finally, the last terms in black, positive 1 times negative 1. The 2 in the middle are like terms. Can you see that they'll get combined to give me plus 1? So it works out exactly, so I know I've factored it. But that's one thing you should be doing, is you should be multiplying it out after the fact to make sure that it's actually worked out. Now that we've factored it, solving for sine theta here, what would make it equal to 0? Be negative of half. Solving for sine theta here would give you 1/3. And this question is half calculator, half non-calculator. It's half non-calculator because one of those two is on your unit circle. Is it the 1/2 or the 1/3? The 1/2. What family? So you can automatically say your reference angle is pi/6. And then in quadrant 1, no, not quadrant 1 because it's negative. It'd be quadrant 3 and quadrant 4. So in quadrant 3, 7 pi/6. Quadrant 4, 11 pi/6. 1/3, though, is not on your unit circle. It's less than 1, so it can be done. So here, you're going to need to use your calculator. So you're going to need to find your reference angle the same way you found your reference angle in grade 11. You're going to type sine inverse in your calculator of positive 1/3. You're going to make sure that your mode is in radians. So one thing that's going to happen on your exam, you're going to switch degrees to radians, radians to degrees, back and forth, back and forth. So you need to be able to do that quickly and easily. And now when I go sine inverse of 1/3, I find out my reference angle is 0.34. Sine is positive, so it will be in quadrant 1, 0.34, and in quadrant 2. How do you find an angle in quadrant 2? So in your head, you're thinking, okay, my reference angle is there. How do I find this angle? 180 minus, but now that we're in radians, we'll do pi minus my reference angle. So I'm going to go pi minus my answer from before, 2.80. Yes, question. You know when to change it to radians and degrees, and this is bad because we're in section E, so we'd have to go all the way back to the beginning when this was solved before question A, and here in the yellow, they'll always state the domain as part of the question. So this domain was stated between 0 and 2 pi. So the domain was in radians, all your answers have to be in radians. If they gave it to you 0 to 360 degrees, then you'd have to have all your answers in degrees. So a degrees question would say, solve for theta where 0 is less than or equal to theta is less than or equal to 360 degrees. Then you're like, oh, I need to be in degrees. If the domain is given in radians, and this is one where we were already on section E, and you don't see that every single time, but that's a great question. How do you know which one, radians or degrees? So here we needed to find our reference angle and then use, right, you might want to put in, that we got that 2.80 by just doing pi minus our reference angle because it was in quadrant 2. Okay, you ready for F? Next level? I know, I'm going to make one up. Because it comes up. Because there's one other thing that happens in grade 11 that we haven't touched on yet. It does happen. Yeah. Okay. Part F. let's do that one. Okay, I'm going to bring it back to grade 11. Here's grade 11. How would you solve 3x squared plus 7x minus 1 equals 0? Okay? If you could factor, I'm kind of giving away a little bit here. It would be 3x and x. That would be the only way to get 3x squared, right? And 1 and 1. Because that's the only way to get 1. Now we need to figure out our plus and minus. But what's our outside? 3. What's our inside? 1. Does 3 and 1 ever make 7? No. This is not going to work. What do you do? If I did the negative 3x and x, that's not a bad idea, and still did 1 and 1, try to figure out my sides, I'm still going to get 3 and 1, and that never adds or subtracts to give me 7. But if I make this a 2, then I don't get a 1 anymore. What do you do when you can't factor? You give up. Excellent. I love that strategy. Wonderful. The quadratic formula, yes. Or complete the square. And guess what? The quadratic formula is on your formula sheet this year. So with the new formula sheet, it's a very last formula on your formula sheet. With the new formula sheet, for the first 2 years, they didn't have the quadratic formula. And then they felt bad that they couldn't ask these questions. So they're like, oh, well, let's give them the quadratic formula so we can ask questions like this. Yeah. That's right. That'd be so much easier. Sorry, Mr. JR, I lost my formula sheet. I will not be able to do math anymore. That would be much easier. Yeah, we have a formula sheet. Do you not have your formula sheet? It's it's blue, I believe. It's blue and it looks like that? I might have given on Thursday. Anybody not have a formula sheet? Okay. Here we go. So on your formula sheet, they have the quadratic formula, just like that. And do they have an O? And they even have the nice explanation above it. 4ax squared plus bx plus c equals 0. Do we have x squared in our equation? No. What do we have squared? We have sine. So instead of x equals, we're going to write sine of theta equals. But the rest of the values, so we're going to get sine of theta equals, what's our b value? So we'll write negative 7 plus or minus. 7 squared is 49. Minus 4 times a is 3. And c is, 4ac, negative 1. All over 2 times 3. We did it in grade 11 too. Do you want to refigure it out?
How did they just randomly come up with that?
Cancel an error until they finally figure it out.
No. Okay, we'll figure out the quadratic formula after this. It's worthwhile. It's a worthwhile thing to do. Okay, so we've got this. We need to simplify this a little bit. So I'm going to get sine of theta equals -7 plus or minus 49 plus 12, 61 over 6. And what this really does is give two equations. One where sine of theta is -7 plus the square root of 61 divided by 6. And one where sine of theta is -7 minus the square root of 61 over 6. This is definitely on the calculator part of the exam. That's why they designed it. So they're like, you have to use your calculator. So what you could do is you could type this fraction into your calculator. I like using the -7 plus the square root of 61, all divided by 6. 0.135. And on the other one, it's the same thing with a minus sign. Push enter there, -2.47. Yes. No, good observation. You can finish this side already. Not possible. Done. Okay? It's bigger than 1. Yeah, you could have that as a fraction. That would mean your opposite side is 2.47, your hypotenuse is 1. Not possible. But this side is possible. So we would need to find our reference angle by doing sine inverse of 0.135. I'm keeping the ... there just to indicate that I'm not rounding anything early. So on my calculator, I'm going to go sine inverse, and I could retype that whole thing that I had before, or I could take all the decimal places. This will give me my reference angle in radians. Oh my goodness. Okay, when they do this on the final exam, it doesn't happen very often, but it's a terrible example. It is just by coincidence. It's really quite amazing, actually, that these numbers are so close. It shouldn't be that close. That's a bad example, because on the exam, if the student wrote this, reference angle equals 0.135, I wouldn't know if you did the math or you just accidentally copied the answer twice, which makes it a really bad example. No, it was just, I picked random numbers. It's really quite amazing that it's this close, but it makes me kind of mad because my numbers are so close. So you get a little bit of amazement. That's good. I guess you should like that in class. That they're, wow, that's good. That's nice. Yeah, we could, let's put a couple more decimal places in our notes just so we feel better. This one has a 0, this one has a 5. There we go. They're totally different now. And if that's my reference angle, since sine is positive, my answers would be in quadrant 1, 0.1355, and in quadrant 2, where I would have to do 180 minus my reference angle in degrees, pi minus my reference angle in radians, 3.006. And those would be my two answers. If you wrote sine of theta is 0.135, but you didn't show your work for your reference angle, you'd put the marker in a dilemma. So,
And then is it really just up to whether they're nice or not?
yeah, like there's a couple, I think, there's a couple just around this angle. See what's in, I think maybe another one. Sine, see if this one is also close. Sine of 1/7 and sine inverse of 1/7. Too close again. So it's just around that fraction. So our fraction was even closer, 0.135. Ooh, which makes you wonder, there is one that's perfectly the same. That would be a whole nother thing to figure out. But someone had said, where does the quadratic formula come from? Okay. The idea comes from here. If you had a parabola in the vertex form, let's say I have 2x plus 3 squared minus 7 equals 0. If it was in vertex form, then I could get the squared by itself by moving the 7 over and dividing by 2. I'll just write 3.5 so we have a decimal. And then once the squared thing is by itself, I could square root both sides. Remember the plus or minus. And then move my 3 over to the other side. Put that into my calculator and get the answer. So if it's in the squared form, I could get my squared by itself and square root. In grade 11, you learned that if something wasn't, we'll do even nicer numbers. If something wasn't in the squared form, we could factor the 2 out of this to make this 6x. And then say, if I wanted this to be something perfectly squared, I would need a plus 9 there. That would make this x plus 3 squared. But if this is going to be a 9 there, I've actually added 18 to this side of the equation. So I would need to add 18 to the other side of the equation to keep it balanced. But now that I've got something squared, I could move my 1 over to the other side, get my squared by itself by dividing by 2. So 17 divided by 2, 8.5, square root it, and solve. So if I can change something that has an x squared into an x into something just squared, then I could get that thing that's just squared by itself and square root it. So you practice a number of times with numbers to start realizing what is the pattern that I need to do to solve this. How do I get something squared? How did I know that this was a 9? What was my hint that told me I needed to put a 9 here? The 6 was my hint. Because if I factored something out and FOILed it, to get that 6, I need 3x and 3x to get 6. And if I had 3x and 3x, then I'd have to have 9 there to make it work. So we do numerous examples with numbers, recognize some patterns, and then say, well, let's do those same patterns with A, B, and C. So I had the 2 out front here. What did I do with that 2? I took it out of this term and this term. So in algebra, I would factor out that A out of the first and the second term. The next thing I did is I made this x plus something squared. This number here was half of that number, always. So I would just take half of b over a, b over 2a. And then this number here was always that number squared. So if I take b over 2a and I square it, I'd have to add b squared over 4a squared. What have I actually done to that side? I've actually added b squared over 4a. So I'm going to need to add b squared over 4a to that side. Same thing that I did here with the 18, because I added 18 to this side, I needed to add 18 to that side. Next thing we did to solve the equation, we tried to get our thing that was squared by itself. So how do I get my thing that's squared by itself? I would have to move the c over to the other side. So I'd get b squared over 4a squared minus c. Still have an a out in front. And here, they were numbers that allowed me to combine them nicely. Here they're fractions. How do you subtract fractions? Need a common denominator. So I'll multiply this by 4a squared over, oops, not a squared. It's just an a. 4a and 4a, right? Because when that a got multiplied, there'd only be one a left on the bottom, leaving me with b squared minus 4ac all over 4a. On this side, I still have that a in front. What would I have to do to get rid of that a? Divide both sides by a, yes. Because in the black line here, when this a gets multiplied by this fraction, that a, one of the a's on the bottom would cancel out. And so there would just be a 4a. And so now I divide both sides by a, which would give me a squared back on the bottom. Now you can square root. How do I square root this? Well, that'll just leave me with b over 2a. On this side, I have plus or minus square root of the top. Hey, this is starting to look familiar. B squared minus 4ac. And when you square root the bottom, it's just 2a. How do I get x by itself? I'd have to subtract this on the other side. And notice they already have a common denominator. So you could put them together. And there's your quadratic formula. Just using the pattern that you notice with the numbers and following it through with your letters. So it's not like they just guessed and checked to say, oh, that's how I create a pattern, or that's how I create a formula. It just follows naturally. If you do the same things with variables all the way through, you can always create your formulas. Used to be